Dear students, welcome back. In the previous session, we have discussed about transverse tarsal joint structure. Now in this session, we are going to discuss about transverse tarsal joint functions. In this function, first you should know the axis of transverse tarsal adjoints. Okay. So movements at the transverse tarsal joint are more difficult to study than movement at the ankle or subtalar joint because multiple segments, isn't it? Multiple segments and multiple axes are involved in this transverse tarsal joint. Although the talonavicular and calcaneocuboidal joints have some independent movement as well as motion, at one is generally accompanied by at least some motion of the other because of their functional bony and ligamentous connections. So because of this multiple segments and axes which are involved in the movements of transverse tarsal joint, we are going to consider some classical works done by Elfman, Mantor and Hicks, who proposed two axes to understand the movements of transverse tarsal joint. One is the longitudinal axis and another one is the oblique axis, around which the talus and calcaneum move on the relatively naviculo-cuboid joint fixed, or naviculo-cuboid unit is fixed. So the studies proposed two axes, one is longitudinal axis and oblique axis, around which the talus and the calcaneum move on a relatively fixed naviculo-cuboid joint. Yes. So now first we are going to discuss about the longitudinal axis of transverse tarsal joint. Okay. Yes. The longitudinal axis is nearly horizontal, being inclined upward from the transverse plane. So here you can see it is inclined 15 degrees upwards from the transverse plane. Okay, here this is the transverse plane and which is angled by 15 degrees. And it is angled 9 degrees. It is angled 9 degrees medially from the sagittal plane. This is the sagittal plane and this is the axis which is making angle 9 degrees medial. So this one is medial to the sagittal plane. Motion around this axis is also triplanar, which is also producing supination, pronation with the components similar in coupling, which we have seen in subtalar joint. So same kind of components which are going to coupling in supination and pronation, but not magnitude. The magnitude of this supination and pronation in the subtalar joint is different from the magnitude of supination and pronation in the transverse tarsal joints. Okay. So here the supination and pronation with the components similar in coupling include both the talus and the calcaneum segments move on the naviculo and cuboid segments. Unlike the axis of subtalar joint, the longitudinal axis of transverse tarsal joint approaches true AP axis, and so here the inversion and eversion components, inversion and eversion components of the transverse tarsal movement predominates. So if you see in the coupling motions of supination and pronation, we will have abduction, adduction, inversion, eversion, as well as dorsiflexion and plantar flexion. Out of all these movements in the longitudinal axis of transverse tarsal joint, because of this axis, the inversion and eversion components will have more degree of movement in the transverse tarsal joint when compared to the subtalar joint. Now we will see the oblique oblique axis of the transverse tarsal joint, or we can also call as transverse axis of the transverse tarsal joints. Okay, so if you see this axis, so the oblique axis of transverse tarsal joint is approximately 57 degrees medial to the sagittal plane. This is the sagittal plane, which is 57 degrees medial to the sagittal plane, as well as if you can see here, this is the axis which is passing at the navicular, isn't it? Navicular, as well as the calcaneum. Yes, here it is 52 degrees superior to the transverse plane. 52 degrees superior to the transverse plane. This triplanar axis also provides supination and pronation with coupled movements of the talus and calcaneus segments moving together on the talus and cuboid bones. Here in this axis, dorsiflexion, plantar flexion and abduction, adduction components predominate over inversion and eversion motions. So because of this axis, by seeing itself, we can say that the abduction and adduction movements, as well as dorsiflexion and the plantar flexion, is going to predominate than the inversion and eversion. Okay. So motions about the longitudinal and oblique axis are difficult to separate and to quantify. Okay, the longitudinal and oblique axis together provide a total range of supination, pronation of the talus and calcaneum, which is about 1/3 to 1/2 of the subtalar range of motions. Okay, so that means in the subtalar joint supination and pronation, the total range of subtalar supination and pronation, in that total subtalar joint supination and pronation, the 1/3 to 1/2 of that range is provided by this transverse tarsal joint. If the transverse tarsal joint is not work properly, then the subtalar joint will not produce such a kind of movements, or such a range of supination and pronation properly. So this is the thing you have to understand related with the axis of the transverse tarsal joint. In the next session, we are going to discuss about transverse tarsal joint function in related to weight bearing, as well as in weight bearing, hind foot pronation, and hindfoot supination, how the transverse tarsal joint motion is going to change in weight bearing hindfoot pronation and hindfoot supination. Thank you.